So welcome everyone to today's webinar. We're going to be talking about building agentic systems with Dapr and also Dapr Agents. My name is Yaron Schneider. I'm your host. I'm a CTO and co-founder at Diagrid. We are the main contributor for the Dapr project, which I created when I was at Microsoft together with my CEO for Diagrid, Mark Fussell. And today I'm a core maintainer on the Dapr runtime. Happy to be here with you all and talking to you about agentic systems. This is the first webinar out of many where we will cover how Dapr helps you build AI systems with agents or without agents. So we'll start off with this slide that Mark really likes. So I put it here for him, essentially. And this just sets the context about what are AI agents for those of you who don't know, and we'll just spend a little time. This is the Anthropic definition, which Mark likes, and I agree with. So AI agents are systems where they essentially dynamically create their own processes based out of tools, and tools are means to have the agent understand what they can do with the task at hand. And agents are really autonomous. Agents are really useful because they are given autonomy, and the more autonomy they're given, the more they can actually automate, and the automation that they do is actually what translates in the end to real ROI. It's cool tech, it's nice to get started with, but at the end of the day, the business needs to prove that this thing is actually useful for you. And in my view, AI agents are extremely useful because they are the epitome example of pretty much everything I personally always wanted to automate in a very big fashion with a lot of agency, but really couldn't because we were beholden to deterministic workflows and steps that needed to really think about everything and every type of input and output in a workflow. But agents really flip that around. They can produce their own solutions based on very dynamic circumstances, which makes them extremely useful, but also very, very hard to accomplish because of their non-deterministic nature. So let's talk about the path to autonomous agents. There is a lot of talk in the industry about what agents are. And actually, there's lots of cases today where we see this single LLM use case where people are calling this an agent. This is not an agent. This is just a user input talking to an LLM. If you're opening up, ChatGPT, it's not really an agent because it doesn't do anything autonomous on its behalf. It's waiting for your input. It might consult you for stuff, but it's a very simple chat interface where you give an input and get a final answer, which is the output. But then, have augmented LLM agents. And this is really more like augmented LLMs. I wouldn't even call this an agent. I'll edit this slide after. But this is essentially a user talking to the same LLM provider, but now we essentially have some way to do work in a smarter way, meaning when the agent doesn't know what to do, instead of going back for output, for additional input from the user, it can look inside of a toolbox, and that toolbox essentially says, okay, when you're running this problem, you can use this tool, and this might be, getting the weather if the user asks a question about the weather. If we're talking about a question that was asked about our CRM, then the tool might be, a Salesforce tool to connect to the Salesforce system and then return a response. And then we actually want to keep conversation history because we're going to be coming back to the same session. So there is the concept of memory to remember past steps, and then we produce a final output. Now, this can either be an agent or just done through a single LLM provider today. It really depends on your use case and the level of autonomy you give through the tools, right? Because if the tool can actually affect an internal system, then you might say, okay, well, this is crossing the line between just an LLM provider and an agent because it's autonomous and it's making changes, mutable changes in my infrastructure on my behalf. But then we have workflow agents here to the right. And these are pretty interesting because they do take predefined code paths, but now they orchestrate multiple LLM calls and they can achieve a greater level of autonomy. So they give you high control because you essentially create the workflow and you can sanitize inputs, you can sanitize outputs, you can even wait for external events, and you pretty much have a well-deterministic structure, but they can also reach back to get further input. So for example, the wait for event here, we might be asking the LLM question, and then it doesn't know what to do, so it might reach out to another process, wait for an event, then decide by itself that this process is good to go, and then it'll continue calling to other LLMs to continue the work. But this is all really deterministic, right? We're just orchestrating a bunch of LLM calls. And what's really interesting is the reasoning agent. So this pattern is essentially reasoning and planning based on the input that is given to it. And this is following something called a chain of thought, where you essentially give it a task, and then the agent takes this task, he reasons about it, it plans, maybe it has a max iteration concept of the number of times it's actually going to reflect through the problem, come up with a plan, and then based on how you actually define the agent, it can continue if it has a certain level of confidence, or it might reach back to you or to other agents to review the plan and then continue and take an action. And this action, again, can be done via a set of tools. So let's say that we have a travel agent and we want to plan the best vacation possible. So the agent's going to reason about what the best paths are. It might do that itself, or it might call to a different agent. Then it'll plan, and then it'll actually look inside of its toolbox to be able to talk to a provider like Expedia, for example, to be able to take the appropriate action and schedule the vacation for us. So I would say this is a good example of an agent, well, because it's pretty autonomous if we give it the ability to book flights and spend money on our behalf, which is, quite scary, but this is where we're going. And then the outmost level of autonomy is with what we call agent meshes, which are individual agents where each one of them might have autonomy over its own domain, and they can make changes into different systems, but they all kind of collaborate to achieve a single task. So in this case, observability, for example, is extremely important, because you have multiple agents, not just one, that's doing something. And just like in a microservices architecture, it's extremely difficult to observe stuff that runs in multiples, not something that is singular and is very, very easy to just reason about. They can do a whole range of things, from complex task automation and handle unpredictable environments. But while agents can handle unpredictable environments because they increase non-determinism, they can also lead to unpredictable environments if they're not doing the right thing, which you want them to do. So observability into these agent meshes is extremely important. And again, the more autonomy they're given, the more they can do, the more they can automate. The more they can automate, the more ROI you get. But if something goes wrong, then the potential catastrophic outcome of that is kind of like increasing linearly with the benefits they can give you. So the current state of agentic adoption, I think this is fairly agreed upon, is that they're almost all in early stage. There's only just a very handful of companies that have taken agents into production. It's POCs and demos for the most part, running on single machines, not running in large distributed environments. There are a few use cases of companies who have run this into production and are writing about their journeys and stories from the trenches. But the great majority of them are still very early stage. Recently, Gartner released an article that says that over 40% of all agentic AI projects will be canceled by the end of 2027. I think one important thing about this is to consider that they're talking about 40% of agentic AI projects that are being developed now. And the reason is that there are two sides to agentic adoption today. One of them is the technical side, which is just trying out the tech and seeing, well, if it can actually do what we want it to do, and if it can fit our enterprise domain. And then the other side is the technical side, which needs to find a business justification, meaning we need to show ROI. And that is still a little bit flubby. There are lots of product teams, business teams who are trying to see how agentic systems can, be more than hype and actually provide tangible value. And so a lot of that today is a bit vague. So Gartner predicts that there will be more clarity, but it's also predicted that there will be many more new agentic AI projects once these tech frameworks mature and people are able to understand exactly how to drive very clear ROI for their agentic projects. But then again, with all that, we're seeing agent frameworks pop up like mushrooms after the rain, and there's many. I think these ones here are very well known. We have Autogen semantic kernel from the house of Microsoft, and then LangChain and LangGraph, which also has two agentic frameworks today, and it's kind of coalescing on LangGraph. Google and AWS Trends, which is not in here as a mushroom, also released their own, and they're very much tied into the cloud provider ecosystem. OpenAI is tied to OpenAI, obviously, into its models. and there's a few more others. So all of those are great because they give you a lot of flexibility, right? You can try all of them out, pick and choose, see which one resonates with you the most. And they really focus on the following things: LLM abstraction, reasoning. So if you're taking a job, most likely you're writing in Python. There's very few of them that also give you a C# interface, but most of them are Python related. And so they essentially allow you to abstract over LLMs and reasoning because that is embedded within the agentic framework. So you bring in an OpenAI key or an Anthropic key and you're off the races. They also encapsulate tool usage, so you can connect an agent to tools so that if it faces a task that it doesn't know how to complete, it'll go and see what tools are available and then take the tool of choice and run with it. It focuses on roles and responsibilities. So an agent has a role and it has a responsibility. So you give an agent an instruction and a goal to complete. And they're also focused on what we call basic workflows. So have the agent perform a bunch of tasks. And some of them, like LangGraph, actually allow you to connect nodes to edges and create a pretty complex graph of agents that are working together. Multi-agent collaboration is also a focus of some, not all of those agentic frameworks. Many of those I showed in the previous example actually do not have any concept of multi-agent collaboration. And even in those that do, it's fairly simple. But that is mostly around getting multiple agents to own a certain domain, be encapsulated, be isolated, just like a solid single-use microservice where each agent does what it needs, but then collaborates in the greater task of accomplishing whatever it needs to do. And ambient agents are agents that do not necessarily work based on user input. So they're not like your regular chat interface agents. They are agents that listen to incoming events, basing their work on streams of events. And these events are a digital event. They might come in from something like Kafka or a, X feed or any form of streaming event feed from any type of system. And then they are extremely autonomous because they take the event and they process the event, and they are starting off a workflow based on that specific event. But a lot of these agentic frameworks are missing a whole lot of stuff that is going to be extremely important once they're actually taken beyond the POC stage and into production. So let's just talk about a few of them. And I think these are the most important ones, and I put them here. So for LLM abstraction and reasoning, that's great. But just think about all of the round trips your data is taking. If you have a multi-agent architecture and your agent has multiple tasks, the user prompt might go into the LLM, and that LLM might send it to a database and then take the database query and send it to another LLM. And the data can essentially be augmented with other data that is coming from your databases or caches or any form of data lake that you have. And PII data can be added to it at any given point in time. And there is no knowing today inside of that entire pipeline that the PII obfuscation is actually taking place and that your data is sensitive, that your sensitive data is being kept secure. When it comes to tool usage, integrating with protocols like MCP, all of that is extremely bare bones today. There is very little authentication being made, and even the authentication that is being proposed inside of the MCP protocol is being heavily criticized because it's happening inside of the MCP client. So all of the authentication code is now being done inside of the code that's connecting to the MCP servers within the agents themselves. Error handling is almost non-existent. So, what do you do when the MCP server is down or when it's returning errors? Everything is autonomous. You don't have a great level of control. And so making sure that your agents are resilient to failures becomes extra important. And essentially all agentic frameworks are missing those very basic resiliency error handling. When it comes to roles and responsibilities, great. We can let agents talk to each other through protocols like A2A from Google, who have recently made their way into the Linux Foundation, but there isn't any common way to, do very basic stuff like ACL, right? You have a bunch of agents and you want to be able to delegate tasks between one agent to the other, but you only want one agent to allow the calling agent to perform a single task, because these agents might be collaborating with other agents for other tasks, right? So you might have agent 1, 2, and 3 doing one thing, and then agent 2, 4, and 5 doing something else. And you want to make sure that agent 4 can only talk to agent 2, but not to agent 1 which is a completely different agent mesh altogether. So how do you do authorization and ACL at scale? And when these agents do talk via A2A, there is no concept of MTLS. So there is no identity that's being embedded into every agent. There is no concept of encryption, automatic encryption of all the data that goes between those agents, which we have surmised before can contain sensitive information. And basic workflows. So agents do have workflows, but a lot of them are just missing the extremely crucial step of durability and step persistence. And we're going to take a look at that later. But suffice to say, this is extremely important, because if you have a workflow of 100 steps with an agent and it crashes at step 99 out of 100, you do not want to start right from the very beginning. That can have catastrophic consequences for your entire workflow. When it comes to multi-agent collaboration, all of the agents today that are communicating via A2A, they're doing this synchronously, meaning one agent calls to the next, and we're going to take a look at that in a second where this fails us. But what we also want to do is, perform asynchronous communication. There is literally no way today for agents to be able to just send off a message and wait for a response in a synchronous way through event-driven architectures. And they're also missing agent discovery. So if you have an agent mesh today, you need to hard code the address of the target agent. That's like picking up your phone and manually inserting the phone number of whoever you want to call, instead of just going into your contact page list and picking up a name and then calling that person. Wouldn't that be much easier? And then ambient agents that are operating on event streams, there is no concept of an eventing ingestion layer. You have to be on the hook for writing a lot of boilerplate code just to be able to ingest event streams, and that's not part of your core business. Some people would argue that even writing the agentic code is not part of your core business. All you want to do is essentially write a prompt and have the agentic system handle what you want to do. That's the promise of it. But now you need to understand agentic frameworks. And now if you want them to work based on event streams, you need to understand how to do event streaming properly with everything that comes with it: partitioning, consumer groups, at least once guarantees, cloud events, all of that good stuff. And this is really where Dapr comes in as what we see as a foundational piece of AI infrastructure, because AI agents are essentially distributed systems with non-deterministic capabilities, which are LLMs that are giving it the non-deterministic flavor. And from all of those Dapr building blocks, there are a few that we can pull that can actually serve as the underlying infrastructure for all of those agentic frameworks. And it doesn't matter if you're using Crew AI or LangGraph or LangChain or Llama Index workflows or Dapr's very own Dapr agents. You can take all of those APIs and you can make them imbued and embed these really powerful capabilities into each one of those agentic frameworks. So let's start with workflows. You can take any agentic framework today and just make it durable by using Dapr workflows to wrap those agentic operations inside of it. Do you want to create an ambient mesh architecture? Yeah, you can just use Dapr pub sub. You essentially abstract all of the message broker semantics from it, and Dapr will make sure to make your agentic architecture event-driven right from the beginning. Do you want to discover other agents and also drive MTLS all the way through? You can use Dapr service invocation to discover other agents, which in 1.16 now supports SSC, which is an HTTP protocol that is used for streaming between A2A agents and also between agents and MCP servers. Do you want to use Dapr's state management layer to be able to save agent memory in your own database of choice? Well, you can just take the Dapr state client, put it inside of your agent code, and save everything there. I'm going to show an example of that. On the bottom right here, we've got conversation. This is a rather new API in Dapr that we're actually moving to beta very soon, and you can use that to bring you PII data obfuscation and prompt caching to every input that is going inside of your LLM. So if you have your data moving around and you're concerned about it picking up information that it shouldn't have, whether it's coming from your existing systems or a data set that you trained your own custom model on, no problem. Dapr will give you that out of the box without you needing to do anything or connect to any third-party system to achieve that. It's a built-in capability within the Dapr conversation API. And then finally, one of the most important things is once you connect your A2A agent or just regular agent or MCP server to Dapr, you can kick off authentication. So if you have two agents talking to each other, Dapr can actually kick off an auth to workflow. It can connect to your enterprise identity provider. Every call will be authenticated, and this will actually solve one of the most long-running criticisms on A2A and authentication today, where authentication needs to happen within the agent code, and that also opens up the attack surface. Here, all of the authentication is actually taking place outside of the process that's actually running the agent. It's externalized to Dapr, and you can also drive rate limiting, and this applies to agent-to-agent communication with A2A, or if an agent wants to pick up a tool from MCP as well. Now, we've got resiliency, observability, and security. We will cover these in later webinars, but suffice to say, Dapr provides mutual authentication for all agent-to-agent communication. Observability, I'm not going to spend too much on. Actually, a lot of agentic frameworks, they have great observability capabilities inside of them. A lot of them are really tied into paid services from the companies that created them, but some of them also have open telemetry. So with Dapr, you'll get built-in open telemetry, but that's not really the most crucial thing, because most of these agentic frameworks do the job pretty properly. Resiliency is actually quite crucial. This will allow you to handle failures. Remember, we said AI agents are extremely autonomous. And so if one of your downstream agents fails, you want to make sure that the agent that's calling it can actually retry, and that it's not degrading its performance based on the agent that is currently down. So you can put things like circuit breakers in play to allow some calls to take priority over other calls in your workflows, which is, I think, really important for the overall reliability of these agentic systems. So let's take a look at some of the stuff that Dapr provides agentic frameworks. Let's take Crew AI, and we're going to see a demo of that in a sec. So we've got the Crew AI code, and Crew AI has the concept of Crew AI flows, and it's essentially a workflow that allows you to kick off some tasks, but again, it's not persistent. And with Dapr, you actually get this persistence because you make Crew AI completely durable. So if it fails at any point, Dapr will make sure it picks back up where it left off. Dapr will also provide agent discovery, meaning Crew AI agents can discover each other via a contact list type of thing through Dapr service invocation. It'll provide access control, so Crew AI agents can decide who can contact what and do what. And event streaming will be given to Crew AI agents via Dapr PubSub. So Dapr will be able to, it can stream events into Crew AI agents and have those agents become ambient agents right off the bat and pick off that work. And if we're using A2A to talk between Crew AI agents, then Dapr will add authentication, connecting into your Auth2 provider, or allowing you to actually use any one of the supported Dapr middleware authentication providers that we have in our components. MCP authentication, same thing. And then Crew AI does not have any form of retries and rate limits built in place, but if you add Dapr to it, it will have this. So Dapr can really add this enterprise level grade battle tested features into existing frameworks, and same with LangGraph, right? Exactly the same thing. LangGraph, kudos to them. They do have the concept of durable execution, kind of. Out of all of the agentic frameworks, they really seem to understand the importance of it, but it's a very, very hard problem. So it's just at the very beginning of it. So you can do a SQLite provider, which is not good for anything distributed. Anything running in Kubernetes or on multiple VMs will not be able to use that. And they also have a Postgres checkpointer, which only allows you to save to Postgres. But if you're using very, very common databases like MySQL, AWS DynamoDB, Azure Cosmos DB, or anything else, you want to connect them to LangGraph, this is simply not possible. But if you pair up LangGraph and Dapr, it's all possible, because you can just use the Dapr client to get and save the state for your workflow execution steps with LangGraph. And so everything becomes durable and persistent with Dapr. Regarding agent discovery, the access control, event streaming, and all of that other good stuff, it also applies to LangGraph. And then semantic kernel is the most bare bones agentic framework that I've come into contact with, but it can be made a whole lot better with Dapr. And now semantic kernel is also interesting to talk about because it also supports C# in addition to Python, right? So the fact that Dapr is actually polyglot because it has multiple SDKs in multiple languages really allows you to use semantic kernel and not need to worry that you need to run just Python or just C#. If you want to talk to Dapr, Dapr will essentially support any type of client that is used by semantic kernel, or even if you're using Spring AI for Java, for example, which is kind of like an agentic framework for the Spring Boot ecosystem, Dapr will support that out of the box as well, since we have a Dapr Java SDK. So let's talk a little bit about how A2A, the agent-to-agent protocol from Google, recently made its way into the Linux Foundation, is prone to message loss. It's completely synchronous, and A2A really is an HTTP server exposing some agent capabilities via a RESTful API with a JSON payload. So if we have agent 1 calling agent 2, and agent 2 dies for whatever reason, can be a scale-out event, can be a cluster shutdown, could be a network outage, can be a cloud provider outage, whatever, then agent 1 is essentially at a broken state because the task contact is lost. Now, this is just a very simple, issue of a microservice calling another microservice, and it's totally dependent on it. So there is very, very high coupling between agent 1 here and agent 2. And A2A does not support any form of event-driven communications. But with Dapr, we can actually introduce asynchronous A2A, which that we will be releasing a lot of content about, because Dapr essentially becomes your focal point for distributing task delegation. So you have agent 1, which delegates a task in an asynchronous way to Dapr. Dapr takes care of all of the boilerplate code for talking to the message broker. It takes the agent JSON serializable interface, and because Dapr talks cloud events and JSON payloads by default, it all comes in very, very nicely into play, because when agent 2 consumes the event, by getting the cloud event from Dapr, it'll actually have the ID of the agent that published the message. So it'll actually have kind of like the ID validated twice, because the ID will be inserted into the A2A task that was being produced, and then Dapr will actually validate it that the agent that sent the message is actually the same one that published the A2A event, because Dapr does have the concept of an app ID. So it'll consume the event through Dapr. Again, doesn't need to do anything about contacting a message queue, understanding how pub subsystems need to behave, not needing to understand things about topics or how to consume them or how to awk them. You essentially bring in the Dapr client, you consume the event, and then once the task is done, agent 2 can then publish a message, which is a completion message back to agent 1. Now, you can also do this with workflows, with raising events. But for A2A, it's going to be a bit less useful. So this is something really great that Dapr can introduce. So it can facilitate secure communication with TLS and authentication for synchronous calls with A2A, but it can also allow you to do asynchronous A2A, which in a lot of cases just makes a lot of sense, especially if durability is important to you. Now let's talk a little bit about Dapr Agents. So Dapr can help agentic systems become production ready and enterprise ready, and we're going to see a demo of that. But we also have the concept of a full-fledged agentic system, which is much easier to run, because all of those concepts I talked about before, which are step-by-step, stateful execution, authentication, all of that stuff is just embedded within Dapr Agents. So Dapr Agents are extremely easy to write. You essentially define an agent, and you can take a look at the GitHub repository. We'll see a demo in a sec. And then you can just, you're off to the races, because they offer durable agents. So any tasks or a number of tasks that are being kicked off by the agent will be persisted by default. We are actually changing the name of the agents in Dapr Agents as soon as next week to be called durable agents. And then you'll also be able to run, non-durable agents if you just want to get started quickly. But the durable agents are definitely the preferred path, because they are persisted with their state. So Dapr Agents are also cloud native and decoupled infrastructure, because they imbue the Dapr eventing ecosystem inside of them, meaning you can just bring in your pub sub and just tell Dapr which pub sub to use via a name. So you can use Kafka or AWS SQS or Azure Service Bus, and there is no code inside of your code that is tightly coupled to any of those SDKs. It can allow you to choose multiple LLMs and state stores to use to save the state. And then, of course, Dapr Agents is really the only vendor-neutral agentic framework out there today. There is no other vendor-neutral framework, which might be important to some people who are looking to run, in multi-cloud environments, don't want to get vendor locked in and bogged down into one specific implementation, or are just generally afraid from a business license change, which is something that has been on the news quite a lot in recent years, with companies moving off from Apache 2 licenses and MIT licenses into business licenses, where companies wake up one day and they find out that now they're competing with that specific company because they built a platform based on that open source project. Now they need to pay them money. So all of that stuff is essentially a gone concern with Dapr Agents. Okay, let's start with the slides and take a look at some code. So let's take a look at Crew AI. And I'm going to be running a Crew AI agent here completely without Dapr. And what I've got here is a research analyst, and it's just researching and summarizing tech news. We can see that we have two tasks, task 1 and task 2. And it's just going to run, task 1 and run task 2 here. And yeah, that's essentially it. So, okay, this is not the code I want to show you. Let's run it without Dapr first. It's actually very similar code. So we've got the same tasks here, just those two crews, agent task 1, agent task 2, and then we are off to the races. So yeah, and what we are doing here is essentially just running the sequence. So we have these two results, and this is a workflow. We're running task 1, running task 2. We're kicking off the crews here. And actually, let me run this real quick, because Crew AI, as you'll see, it does take a while to spin up. So let's just run Crew AI. AI no Dapr. And this should just start Crew AI here. So running agent task 1. And again, this kickoff thing takes a bit to start. So we will be waiting here, and we can see that it's done. So the Crew AI agent ran, and we can see that it ran these two tasks. One was to find the latest news about artificial intelligence, and the other one was to summarize. So we have task result 1, and we will also have here task result 2, which is being highlighted. I'm just going to zoom in a little more. It's quite difficult for me to see the screen now, but I gather it should be easier for you. Okay, so this is great. And what we're going to do now is essentially fill the workflow, right? So we're going to go into agent task 2, and let's try and do something like this. Let's do sys.exit. And now we're essentially going to crash before agent task 2 is complete. So we will be running this again. And yeah, these agents take a while to spin up. Because what I found with Crew AI, and I don't know if there's anyone here in chat that is using Crew AI, is that they take a while to spin up, but they're really meant to be long-running processes, right? So they're powerful, but not that great for like serverless environments. Okay, cool. So we have crashed here, and we see that there is no output, right? Because we essentially had the agent task 2 not complete. So I'm going to just remove this, and we are going to kick this all over again. And what we will see is that it's actually starting with agent task 1. So the entire workflow is not persistent. It's starting it right from the very beginning. Now imagine you have 100 tasks here, and this can get extremely costly and extremely complex. So now we are going to make those durable and much more cost-effective with Dapr. So I'm transitioning here to a version of Crew AI that is essentially Daprized, and it looks pretty much the same. We have those agents. These are Crew AI agents, and we've just added this line of code. Just to give you an overview, we essentially went from 52 lines of code to 70 lines of code, so 18 additional lines of code, not more, not much more to make this entire thing durable. And well, what we're doing here is we are defining a workflow, and the workflow essentially wraps these two agent tasks inside of Dapr activities. So because these Crew AI agents take a while to spin up, let me just fire this off. So we will do Dapr run, and let's give it a new ID, just not to override my previous attempt. And this should run Dapr now with Crew AI. And this is going to take a few seconds to spin up. And hopefully I don't have the code that exits. Yeah, we can see that they're starting off. So agent task 1 is now kicking off, and agent task 2 is kicking off. And yeah, so these are essentially tasks, and we can see the execution here. So it finished, and this is now Dapperized. So we have agent task 1 running, agent task 2 running, and it's exactly the same output. Now we're going to do the exact same thing, and we are going to kill and really mess with everything. So this is an extremely catastrophic failure. Wait, let's do this before the kickoff so we don't have to wait so long for the agent to spin up. And so this is agent 2. It's essentially going to crash after we've defined the crew and the agents. And while this spins up, we're actually going to talk a little bit about Crew AI. I really like this framework, by the way. So yeah, let's give this one a new idea. We're going to start completing the workflow. And we will just go here and do Dapr run. Let's give it a new ID. Yep. And let's kick this off. Cool. And this is going to start. And once it reaches agent task 2, it's essentially going to provide a catastrophic failure for us, which is going to fail the entire workflow. So this task should just run fine. And we can see we define a crew here, and a crew is a collection of agents, and an agent can have multiple tasks that it's doing. So Dapr Workflows is such a flexible programming model that it can actually wrap around any form of like graph computation that you have in mind, right? You can wrap a single crew inside of Dapr Workflow. You can wrap multiple crews inside of a Dapr Workflow. And we can see now that the workflow has completed. So we ran agent task 1, that ran to completion, but agent task 2 has timed out because we've crashed the thing. So what we're going to do now is, first of all, remove this one because we want to allow it to run to completion, basically simulate the agent coming back up in a running way. And then real quickly, I'm just going to remove this line, which is not going to schedule a new workflow. It's going to start off the existing workflow, so I'm not going to change the instance ID. And I'm just going to do Dapr run again and run this thing. And just want to make sure I didn't, yeah, I removed that thing over there. So yeah, this is, when I said the thing, I meant the code that's making it exit, because we do want this thing to run into completion. And so this ran all over again. And now we can see that it started with agent tasks 2. So the workflow, essentially the Crew AI workflow, continued where it left off. It did not run the first agent task, which means we've saved that LLM call. And if this were a really autonomous, highly scalable, complex workflow that really automated most of our infrastructure and consisted of, let's say, just to be very dramatic, 500 steps, which really, if we really want to drive a lot of business value out of agents, this is the types of automation and agency they need to get to. Then in a 500-step scenario, let's say we failed at 250, we really don't want to start the entire thing from the very beginning. And so the entire workflow was made durable. We kept the programming model for Crew AI. Okay, so this is just a Crew AI and Dapr example. Let's take a look at LangGraph. So LangGraph is another very popular agentic framework, which I also really, really like. And it also has the concept of a workflow model. So in here, we're not going to be using Dapr workflows. We're just going to be using the very simple workflow model that LangGraph already has, because we don't want to force people to use Dapr workflows if they don't. But the question is, can we still use the Dapr stateful capabilities to make them resilient and be able to save the state in a variety of databases? And the answer is yes, of course. So, by the way, we could use LangChain agents and connect those LangChain agents to Dapr workflows, which would be very similar to what we've just seen with Crew AI. In this example, I'm using LangGraph, which is the workflow model. So, there is no Dapr workflows code, as you can see here. The only thing that we are writing is this piece of code that we will make available open source upstream in Dapr, and that's called the Dapr checkpointer. So today, out of the box, LangGraph provides only 2 checkpointers for Postgres and SQLite. SQLite is like for very local development or single machine type of scenarios. But the Dapr checkpointer essentially makes all of that distributed. This is code I've written to essentially take the checkpoint data structure that LangGraph expects and just serialize it into data that Dapr has, and then just save it. So this is a very small amount of code you need to write in order to get Dapr integrated, but even this code you're not going to have to write because this is going to be made available soon through the Dapr Python SDK. So the only thing you'll need to do to combine LangGraph and Dapr is go from dapr.client, import Dapr checkpointer, and then you will just instantiate it like that with the Dapr saver and just give it to LangGraph when you're compiling your graph, and literally that's it. So let's see if that is working for us. Let me kick off the LangGraph agent, which is connecting to GPT 3.5, not such a good model. And the prompt is telling me something amazing about the human brain. Let's do Dapr run LangGraph agent. So let me just bring this back up. The console window and the final conversation is done. We can see that it ran into completion. And we theoretically should have the state now saved inside of Dapr. So my Dapr state component by default on my machine saves the state to Redis. Dapr supports over 30 different databases. So think about the opportunities that it gives you to save the state into any database that you're using. And we're going to go into Redis Insights here and take a look at what we have. And the latest entry here is called LangAgent agent. And we can take a look at the hash. And if we take a look at what was saved here, then we can see Dapr essentially saved all of the LangGraph specific state execution. So we can see the branch 2. We can see all of the data structure that LangGraph uses internally, including the messages, and it's all saved within a Dapr-enabled state store. Now, this brings to you not only the ability to save the state in whatever database you're using, but you can also get all of the other Dapr state store building blocks, right? You can put resiliency policies against the database. So you can make your database resilient if you have lots of agents trying to write the same state. You can have e-tags and record versioning, and you can have client-side and encryption and decryption, right? So, if let's say you're using Postgres natively through LangGraph and you're saving the data to a Postgres database, it essentially gets saved as plain text. But Dapr, via its state API, has a client-side and encryption and decryption capability, which will make sure Dapr will encrypt the message before it hits Postgres, and then it'll decrypt it right before it hands it back into the LangGraph agent. So your data becomes much more secure. And with this capability, you can also provide your own certificates to Dapr, which is highly useful. Add to that all of the metrics that Dapr shows you, and suddenly you can see how many requests your agents are making into your database for getting and saving state, the throughput, the latency, the error rates, all of that good stuff you're getting just by the virtue of using this Dapr checkpoint saver and combining it with LangGraph agents. So we're almost at time. Let's move on and talk about Dapr Agents, which is an amazing agentic framework that is being co-authored and being worked on heavily. So Dapr Agents can do a lot of stuff. What I encourage everyone to do is just going to github.com/Dapr/Dapr Agents, take a look at the quick starts and just start following them. What I'm going to do here is actually run an agent mesh. This is a very complex example of how we run multiple agents together that are collaborating. This is an example that I like to show. I kind of show it a lot. This is about allowing agents to figure out a task for how to take the One Ring to Mordor with Lord of the Rings. So we have different services. You can see here on the left, we have Elf, Hobbit, and Wizard, which is Legolas, Frodo, and Gandalf. And this is essentially how you just define an agent in Dapr. Extremely easy. And this assistant agent from next week is going to be called Durable Agent. So we give it a name, we give the role, we give it a goal and instruction. So we're instructing it to speak like Legolas. Here, we don't have to bring in any custom code. If you know Dapr, and you want to connect it to something like Cruya or LangGraph, there's a bit of code you're going to need to bring in to do pub/sub. But with Dapr, it essentially only becomes a property on the agent itself. You define a pub/sub component to tell it which one to use. Same thing for the state store. This is just configuration to tell Dapr which one to use, right? So we have message pub/sub, and if we take a look at the component, this is message pub/sub. So in this case, we're using Redis, but Dapr supports over 15 different message buses. You can use each one of them, and Dapr will actually use those to send messages and collaborate between those agents. So by the way, when we talked earlier about HTTP being a very error-prone protocol, with Dapr Agents, you essentially get that durability built in because Dapr Agents collaborate through an event-driven architecture using Dapr as the entry point. which will make sure that if one agent drops and then comes back up, it will pick up the message off of the queue. So, we have this Hobbit one as well, which looks exactly the same. All of these agents look alike. It's just getting a different goal because Frodo, as the carrier of the ring, needs to resist its corruptive power. So we'll see if the LLM has any ideas about how to do that. And essentially, all of the rest of the configuration is the same. So we also have some client code, which is how to kick this off. You can send an HTTP request to kick off the workflow with the task, how to get to Mordor. We all need help. And you can also make this an ambient agent. This is something that a pretty up-and-coming architecture where agents pick up on messages coming in from queues. So this is just essentially an orchestrator picking a message from a pub sub and doing it. Today. We'll be using the HTTP one. So we're almost out of time. I will just run this quickly. I'm just going to do Dapr run. Dapr, by the way, as what I have here is a CLI tool that allows me to run Dapr locally. And I am going to run Dapr random. So this is going to pick the agent to talk to in random. And now these agents will take a second to spin up because this is a multi-agent collaboration, right? So what we're doing here is we're bringing up these three agents, which are the Hobbit agent, the Wizard agent, and the Elf agent. And then we have those workflows. So we're taking the tasks. And what Dapr is doing is it's essentially distributing the tasks to all of the agents, and these agents will start talking to each other, right? And as each one of those agents receives the tasks, it will actually send its opinions to the other agents, and then they will they talk to each other until they are deciding that the task is complete and that they have a very good plan for how to take this to Mordor. So yeah, it looks like we are essentially complete, and you can view this inside of your own distributed system of choice for distributed tracing. But something that Dapr Agents does, which is extremely useful, is to be able to provide just a JSON that is giving you full auditability into what the agent did. So for example, here we can see Legolas, we can see the output. If we go into the Hobbit one and we look at that, we can see exactly everything that the agent has done. We can see that the source was a random orchestrator where the collaborating agents were picked at random in terms of their how the agent is going to pick the next participant. But we can also have round robin, and we can also have LLM. So the LLM provider is essentially going to let the LLM decide which one should go next. And these agents also output you can configure them to output their text inside of the text window. And of course, if you're connecting Dapr to a distributed system, like Jaeger or another form of system like X-Ray or anything on Azure, GCP Stack Driver, you can actually see the call graph on there.